There's been this buzz in the tech world about a secret project, a piece of software that could literally change everything. Well, guess what? It's not a secret anymore. So today, we're going to unpack how one of the most advanced technologies on Earth was just released to the public.
And it all comes down to this one question that honestly sounds kind of crazy. Why would anyone give away a technology that could redefine medicine, finance, everything, for free? We're going to get into the massive strategy behind that very decision.
I mean, this is the stuff of sci-fi movies, right? This is the kind of tech that nations build secret underground labs for. And yet, with a single click, it's now out there for the entire world. Let's break down exactly how this all went down.
All right, so to really get what's happening here, we need to untangle some of the rumors that have been flying around. Let's dive into the great quantum OS mystery.
Okay, so a little while back, whispers started popping up online about some new quantum OS going open source. And at first, everyone kind of jumped to the conclusion it was Google's Gemini AI project, which, makes sense. They're big in the quantum space. But that turned out to be a classic case of mistaken identity.
But no, the real source, it's a company you might not have heard of, out of Hefei, China, called Origin Quantum. And they're the ones who just did something that has jaws on the floor across the tech industry. They took their crown jewel, their most valuable software, and just put it online for anyone to use.
Now this software, it's called Origin Pilot, and it's not some brand new thing. It's been around since 2021, but then this February, they did something massive. They made it open source. And listen, this isn't some dumbed-down for educational use only version. This is the real deal, the exact same system that powers their state-of-the-art Wukong quantum computer.
Okay, so this begs the big question, right? What is a quantum operating system anyway? And why is it such a huge deal? Well, probably the best way to think about it is as the computer's soft heart.
Yeah, that's actually a quote from one of their chief scientists, and it's just perfect. A QoS is that absolutely essential layer of software that lets the quantum hardware, the actual physical qubits, talk to the applications and actually do stuff. It's doing the same job your computer's OS does, managing stuff, scheduling tasks, but it's doing it in an environment that is unbelievably more complicated.
So let's break that down. You know Windows, you know Mac OS, right? Their whole job is to manage bits. Simple on or off, a 1 or a 0. Easy enough. A quantum OS, though, has this ridiculously difficult job of managing something called a qubit and keeping its incredibly fragile quantum state stable enough to actually perform a calculation.
And this is seriously the best analogy I've ever heard for this. A regular computer bit is just a light switch. It is on or it is off. That's it. A qubit, because of this wild quantum principle called superposition, is more like a dimmer switch. It can be on, it can be off, or it can be a whole spectrum of values in between, all at the same time. And that right there, that dimmer switch idea, is where all the mind-bending power of quantum computing comes from.
So where does the OS actually live in this whole setup? It's right smack in the middle of what people call the quantum stack. You've got the physical hardware at the very bottom and the apps people want to use at the very top. The quantum OS is the critical bridge connecting the two. It's the ultimate translator. And without it, you've just got a bunch of really expensive, really cold hardware that can't do a thing.
Which brings us back to that billion-dollar question. Why on earth would you just give this away for free? Well, what if this isn't about giving something away? What if it's a play to create a quantum Android moment?
To understand why this OS is such a big deal, you got to look at what it does. First, it's hardware-agnostic, a fancy way of saying it doesn't care what kind of quantum chip you're using, it can probably run it. Second, it can run multiple quantum jobs at the same time, which is huge for efficiency. And maybe most important of all, it automatically handles the nightmare job of calibrating the qubits, constantly tweaking them to keep them stable and prevent errors.
You see, by putting a really powerful, really flexible OS out there for free, you're not just being generous, you're playing a long game. The strategy is to become the global standard. Think about it. It's the exact same playbook Google used with Android, or that made Linux so dominant. If everyone in the world is learning and building on your platform, your ecosystem becomes the default for the entire industry.
And this move just completely flips the table on how quantum development is done. All of a sudden, you don't need a billion-dollar laboratory to experiment with quantum computing. A university, a startup, even a lone developer can download this OS and start running tasks on real Chinese quantum hardware through the cloud. You're taking this technology out of these super secretive labs and throwing it open to the entire world.
It becomes a global race, and guess what? Their hardware is sitting right at the center of it all.
So let's pull back a bit, because this move didn't happen in a vacuum. Oh no. This is a massive play in what is becoming a very, very serious global quantum race.
Right now, we're basically seeing two completely different philosophies clashing. In the West, huge players like IBM and Google have open-sourced powerful toolkits. Now, it's kind of like they're handing you a box of incredibly advanced engine parts. Amazing stuff, for sure, but you have to build the car. What China just did with Origin Pilot, they basically handed the world the keys to the entire car. It's a fully integrated system ready to go. A top-down approach versus a bottom-up one.
And look, this isn't just a simple US versus China story. It's way more complex than that. Other countries are making huge moves too. Take the UK, for instance. A whole group of companies and universities there are building their own quantum OS called DeltaFlow, trying to create their own standard platform.
Okay. Now, as hyped as I am about all this stuff, we've got to pump the brakes for a second and talk about reality. Because there is a massive gap between the incredible promise of quantum computing and where we are today.
And believe me, the hurdles are huge. First off, the qubits themselves are just ridiculously unstable. They're super sensitive to any kind of disturbance, what scientists call noise. Second, the hardware has to be kept in extreme conditions, often cooled to temperatures colder than deep space just to function at all. And then there's the big one. A powerful quantum computer could, in theory, break most of the encryption that protects our entire digital world.
And this is the thing that keeps cybersecurity experts up at night. It's called Shor's algorithm. It's a formula specifically designed to run on a quantum computer, and it's devastatingly good at solving the exact type of math problem that our modern encryption relies on. This single algorithm is the reason there's a frantic global race to create what's called post-quantum cryptography, new ways to protect our data before it's too late.
But for every scary part, there's a reason to be incredibly optimistic. This is why everyone is racing so hard. The applications could literally change humanity. We're talking about designing life-saving drugs by simulating molecules perfectly, optimizing global shipping routes in seconds, creating revolutionary new materials from scratch, and taking AI to a level we can't even imagine.
And don't for a second think this is all just theoretical stuff happening in a lab. Get this. That Wukong computer running this very OS has already processed more than 10 million tasks from people all over the planet. This system is live, it's running, and a global community is testing its limits right now.
So where does that leave us? The game has changed. This isn't just about who can build the biggest, baddest quantum computer anymore. It's about who can build the software, the ecosystem that everyone wants to use. For the very first time, the keys to the kingdom, a real, fully-fledged quantum OS, are just a download away. The era hasn't just arrived, it's downloadable. The only question now is, what happens next?